So we are continuing to look at exponents, exponential functions today. But we are going to take it a little bit further today, and we're going to look at this in the application process. So I am going to sort of call it story problems. It doesn't really fit into story problems like we've seen them in the past. Okay, so today we are looking at exponential growth and decay. Okay, and that's exactly what it means when something is growing exponentially and when something is decaying or decreasing exponentially. And there are tons of things in the world that are modeled by exponential growth and decay. Okay, so we have this sort of general format that we use for exponential growth and decay, and it always fits the format y equals a, and then in parentheses 1 plus or minus r, all to the x, right? And for this to be an exponential function, we have to have that exponent being an x. So this always stays as an x, and this always stays as a y. Okay, everything else is going to get filled in with a number. Okay, where the numbers that we fill in, our a value is going to be the original value or the starting point. Okay. So whether we're talking about a bank account and the amount of money that is originally in it, whether we are talking about a decrease that's happening in a tournament, it's the original number of people, whether it's the amount of product somebody needs to make to start with, okay, that a value is always the original starting point, the original starting value. And R is going to be whatever the rate is. So a rate is always represented as a percent, but when we're talking about a percent in a mathematical equation, we need that to be represented as a decimal. So that rate or percent as a decimal. Now, the tricky thing with finding the R is that if it's already in the equation, we're going to be able to combine, we'll be able to add or subtract that one with a number. So we might have to do a little bit of math to tell what that R is to start with. Okay, so for example, let's say we have an equation that says y equals 500 times 1 plus 0.2 all to the x. Okay, this tells us that our original value or our starting value is 500 and that our rate, okay, is 0.2 as a decimal. But remember, to turn a decimal into a percent, we are going to multiply that times 100 and it will be 20%. So we have a rate of 20% happening and an original value of 500. But if we look here, right, we can really take 1 plus 0.2. And so we can really have this as y equals 500 times 1.2 to the x. And so what we would have to recognize, right, a is no different. A is still this 500 sitting over here. But we would have to recognize that this is 0.2 larger than 1. And we would have to be able to see that 0.2 separately to be able to find the rate from that, which isn't such a big deal when we have an addition sign, right? No problem, 1.2, it's 0.2. Okay, if there is an addition sign in here, that's talking about exponential growth. But let's say something's getting smaller, and we have, 10,500, and then 1 minus 0.03 to the x. Okay, so this is telling us that our original amount is 10,500. And our rate, again, while we see that 0.3, we're going to multiply that times 100, and our rate will be 3%. Okay, but if we were to actually combine that 1 and that 0.03, this equation would say y equals 10,500 times, in parentheses, 0.97 all to the x. Okay, so here we have to recognize that 0.97 is smaller than 1. And so if we want to see what number that is in our calculator, we would want to do 1 minus 0.97. Right, so if we take 1 minus 0.97, it gives us that 0.03, and so we can find the rate from there. Okay, we just want to make sure that we can find that rate whether or not we see that addition or subtraction sign at all. And so here's how this is going to work when we sort of put it all together and we see what's going on. So let's say we have a problem where Jose opens a bank account and puts in $1,200. It earns 4% interest each month, and we want to represent this as an equation. Okay, so the first thing to understand is that this is talking about how much it earns. Okay, if we are earning money, that means that the price is going up. And so therefore, it is exponential growth. Whenever we are talking about something going up, that means we want to use the addition sign in that formula. So notice right here, right, I have y equals a and then 1 plus r to the x. All we then need to do is fill in the blanks. So we said that the y stays put. Okay, the original value. So A is our original amount. Well, the original amount he put into the bank account was $1,200. Okay, so then in parentheses, we're going to have 1 plus. Now we need our rate. So if this is 4%, but we need 4% as a decimal. To go from a percent to a decimal, we need to divide by 100. Now, some of you might say, well, can I just move the decimal point? Yes, moving the decimal point is doing the exact same thing. So if we do 4 divided by 100, we get 0.04 to the x. Okay, so we could leave the equation in that format, or we could also add these together. So which equation represents this same thing with those values added together? We should have picked y equals 1,200, and then we have 1.04 to the x. This lets us then calculate what the situation will be for our bank account, and we'll read what it says up here, each month. Now, this is a very extreme interest rate earning, but your bank account does grow if you have it in an account that earns money. Okay, so there are different types of accounts you can use at a bank. And if it's one that earns money, it earns money exponentially. Okay, so let's say we want to know how much money you will have in the account after 2 months. Okay, so what amount of money will we have in there after 2 months? Well, after 2 months means we want x to equal 2. So we are going to take this same equation and we are going to plug in 2 for x. So we'll say y equals 1,200 times 1.04 squared. Okay, so in your calculator, I want you to evaluate this. Just type it in exactly how you see it and tell me what value we get out. Okay, we get out 1297.92. Okay, so after 2 months, if Jose didn't touch that money, now he has $1,297.92. What happens if Jose leaves it in the bank for 12 months or 1 year? So if we're leaving it in there for 1 year, that means we want to evaluate this for x being 12. So if we're evaluating this for x equals 12, what are we going to do with that x equals 12? We need to plug that in for x. So we'll now have an equation of y equals 1,200 times 1.04 to the x. So I want you to evaluate this when x equals 12, and what do we get? We get 1921 point. Now we're talking money. So if we're talking money right to the nearest cent, we'd have 24 cents. Okay, so if Jose leaves his money in this account for a year, he goes from having $1,200 to having $1,900. If this process continues, Okay, that number is just going to get larger and larger and larger and continue to grow without adding money to it, but simply because it is earning interest. Okay, so let's look at another example. Let's say that you purchase a home in Westfield, and when you purchase the home, it costs you $225,000. Okay, but we know that the home is going to appreciate. Okay, appreciate means it's going to go up. Okay, the home is going to raise in value by 4% each year. Okay, so if the home is raising in value, are we going to want to use the addition sign or subtraction sign in our formula? We want to use the addition sign. Okay, so if we're doing y equals a times 1 plus r all to the x, what value do we want to plug in for a? We want to plug in our $225,000 because that's the original price. What number do we want to plug in for r? We need to plug this in as a decimal, so we need 0.04, right? We can't just plug that in as a 4, we need it as a 0.04. What equation would be the equivalent representation of this? We should have picked y equals 225,000 and then 1.04x. Now, if it's appreciating by 4% each year, what would we want x to equal if we want to know the value of the home 10 years later? We would need x to equal 10. So I want you to plug this in for 10 and tell me what value you get of the home after 10 years. So in your calculator, you should have plugged in 225,000 and then in parentheses 1.04 up caret 10. And we get out 333,054. Again, it's money, so I'm going to go to the nearest cent. And that means our home is now worth $333,000. It went up over $100,000 in 10 years. And that's exactly actually what's happening here in Westfield and home values, property values going up. Now, we can also talk about exponential decay. Okay, so let's say we're looking at something where the value is going down. So each year, the local country club sponsors a tennis tournament. Play starts with 128 participants, and during each round, half of the players are eliminated. Okay, so if players are eliminated, the number of players are going down. So if we're going down, we are then talking about exponential decay. Okay, so when we're talking about decay, we want to use the subtraction sign. Okay, so we're still using the same format, y equals, where a we want to be the original number. Well, it said it starts with 128 participants. We know we're doing 1 minus something to the x. Now this one we have to think a little bit. It says during each round, half of the players. So we don't see that percent handed to us. We need to decide what percent would represent half. So what percent is going to tell us half of something? We should have picked 50%. Okay, 50% is telling us half of something. So if we want 50% as a decimal, right, we're going to divide 50 by 100, which will give us 0.5. What equation would be equivalent to this? We should have picked y equals 128, and then 1 minus 0.5 is 0.5 to the x. This question then asks us how many players remain after 5 rounds. So if we want to know how many players remain after 5 rounds, what do we want x to equal? We need x to equal 5, okay? So we're going to plug in 5 for x. So you then evaluate this for x equaling 5 and select what value you get. We should have picked, we should have typed into our calculator 128 and then in parentheses 0.5 all to the up caret of 5. And when we do that, we get out an answer of 4. Okay, so there are 4 players left after 5 rounds.